Hello, my name's Steve Draper, and today we're going to be talking about networking foundations. The purpose of this material is to help individuals who are planning on seeking other certifications like CCNA, NetPlus, and kind of give a preview of what's taking place in a networking environment that may not be covered in a traditional classroom environment. The audience should be those career path seekers that are looking for certification, um, and or managers, or those who just have a need to know of what's happening in the networking world. Before we talk about the bits and bytes, we need to get into a little bit of basic life truths as it relates to networking. In life, we have basic life truths such as the sow and reap principle, aka karma. You live by the sword, die by the sword. What comes around goes around. Well, in life, there's also a basic life truth that says in networking, as well as any other decision that happens in our organization, we need to take into account the costs. Our businesses are in business to make money, save money, or not spend money if not needed. And so we find that reason why this is important is because this money is going to become a decision making point in every single decision that happens within our organization, including networking, and has been over the years. Nothing happens in an organization or even in a home unless it makes financial sense. So we'll see this, and the reason why we have this slide is to help us to understand that this will continue to be in the background of our mind why we do certain things. A good example of that would be, for example, resource sharing. Why do we network? Well, one of the reasons we network is because if we have 50 PC users, we don't want to have to purchase 50 printers for each one of them. Instead, we purchase one really decent printer and we attach it to the network and we timeshare that printer amongst the 50 users. Works just fine and it saves money. And again, we come back to the basic foundation or fundamental life truth of, hey, does it make sense financially? File transfer is a daily need. Web surfing, a lot of us cannot imagine going without our YouTube or our whatever it is that we go to every day, our local weather, data mining. Email is a part of our integrated daily life. That's how we communicate. Voice over IP is a really good example of the basic life truth of the return on investment. It was actually discovered that voice over packet could save money over traditional voice. Traditional voice networks actually do a better job of transmitting voice than voice over IP. However, it was discovered that voice over IP does a job that's good enough and it can help save us some money in the long run. So voice over IP is a good reason why we network. Electronic banking, network management, project collaboration, whiteboarding, maybe a group of individuals working on an application using collaboration software, database management, and general business needs. Now, it has been discovered that we need to know what a network is. Now, when we say network, we need to narrow that definition down because the word network has been really beat up, used for a lot of different things. Here on out, we're going to refer to a network as, quote, a data network. So what makes or what creates or what is composed or defines a data network? Well, in a data networking world, we have to have some kind of media. That would be a copper cable, coaxial, twisted pair, fiber optics, some means of transmitting between endpoints. We need the endpoints, which traditionally have been PCs, printers, today include voice over IP phones, but we need to have some endpoint that then connects to a media that allows us to transmit information over that media between the endpoints. We also need some application software that bridges the gap between humanoid and machines. We need to be able to have that I/O, input-output, from a human being, whether it be a microphone, a keyboard, a video camera, input into the machine that then gets converted into machine language, which we'll talk about on the next slide, and then goes from machine to machine and then back out. The application converts it to the humanoid form, whether it be audio, visual, as in a video or something else. And then last but not least, we need to have some kind of rules, protocols between devices on how we send. We can't just begin sending. We need to actually the end devices and the applications have to take in consideration other devices and follow a set of rules on how we transmit and receive the information. Protocols are nothing more than a set of rules, and those are the rules that these devices must follow in order to transmit information. The device on the left says, after you. The device on the right says, thank you. I'll transmit now, and now after you. Why, thank you. Again, we want to make sure that we have some form of order, and that order are going to be protocols. It has been said that you cannot transfer the capital letter A over a wire. Can't be done. You can't really push a letter A over a wire. However, it has been discovered that you can take a series of electronic pulses that would then in turn be interpreted as the letter A. So we can actually take some other form, and that would be the form that the machines understand, and that would be, in the case of wire, it would be voltages, positive or negative. In the case of fiber optic cable, it will be the absence or presence of light. In the case of a device with an antenna, it would be the presence of radio wave power or the absence of power. So we can send some form of pulses that would then be interpreted as the letter A. Now, these pulses are interpreted by these devices and converted into what we refer to as binary, because it's very natural for a machine to speak in, voltage, no voltage, positive voltage, negative voltage, the light is present, the light is off. We use this and call this the binary or the machine language of the machines. For example, a series of zeros and ones in the red that you see here would represent a capital letter A to another machine. We can transfer those through the series of light or radio waves or voltages to the other machines that can then interpret the application, can take those zeros and ones, convert it back into what we understand as a capital letter A. This is the language of machines. It's referred to as binary, and it's the way machines talk to each other. A machine can't talk to each other and say, hey, this is a letter A I'm sending you, but it can send a series of zeros and ones in the form of pulses of voltage, light, or radio wave that would then in turn be interpreted as the letter A. The traffic types that traverse these networks have different categories. There's three major categories. Voice, where we take a codec, a coder decoder, and we take the human voice and we encode that as a series of zeros and ones representing a digital form of that code, transfer it over a data network, and then run it through a codec again, converting it back into the analog wave that humans understand. Video, doing the same thing through a codec, or data. And when I say data, I mean email, I mean file transfer, talking about data. So we have three major categories, and each of the three categories basically have their own characteristics and their needs. And data networking can handle all of those needs, some better than others. Voice, for example, is very sensitive to delay. If you're doing a voice transmission, voice over IP, the information has to be received almost as soon as it's transmitted, because voice getting there late makes no sense. So voice is very sensitive to delay. However, we can lose a considerable number of voice packets and still continue to understand the person on the other end, almost up to 20%. Voice bandwidth, on the other hand, is only about 8K, depends on which codec you use. So very low bandwidth, very sensitive to delay, but we can withstand some loss. Video, on the other hand, has a higher bandwidth. Its delay sensitivity is not so much if we're talking about streaming one-way video like the one you're listening to now, because we do some buffering up front that prevents us from having to have a real-time situation like we do voice. We can also lose some packets in video and still make out the image and the audio. The bandwidth utilization for video, however, is much higher. Data, on the other hand, is going to be delay insensitive. It doesn't matter whether it takes 5 milliseconds, 5 microseconds, or 5 hours for an email to arrive. However, an email has to arrive in the correct order without any corruption in the original form that it was received. So we have voice, video, and data. All of these with different characteristics that network can take care of in regards to delay, loss, sensitivity, and bandwidth.